Day 2, interpreting and comparing rates of change. Read the problem below, then explore different ways to compare rates of change. A biologist studied the growth of two different trees over a 5-year period. At the beginning of the study, she measured each tree's diameter. The biologist took this same measurement each year to determine the growth. The red maple in her study had a starting diameter of 4 inches. If it started at 4 inches, then that's our initial value. So for the red maple, we had the initial value of 4 inches. And we move on. The diameter grew at an average rate of 0.3 inches per year. So if it grew at a rate of 0.3 inches per year, then our rate of change is 0.3 inches. Okay? The graph on the right shows the growth rate of the silver maple tree, which function has a greater rate of change. So then we talk about the silver, and we also need its initial value and rate of change. So the initial value is the starting output, which is here, which is directly between 2 and 4, which is 3. So then we say the rate of change. We need to figure out what that is. So we go from 3 to about 3.5, then from 3.5 to 4, from 4 to 4.5, from 4.5 to 5. So I'm going from 3 to 3.5 to 4 to 4.5, and so on and so forth. So what's happening here is to get from 3 to 3.5 is I add 0.5. And I'm going to continue with this same pattern each year. So our year-over-year change is 0.5 inches per year. So our rate of change for the silver is 0.5 inches. Okay. And the question we're asking is, which function has a greater rate of change? Well, I can go ahead and answer that now, because we see that the red maple has a rate of change of 0.3, while the silver has a rate of change of 0.5. So we would know for a fact that the silver maple has a greater growth rate. And that's our answer for here. And we'll go ahead and answer the questions for this day's lesson. So graphing it. You can use a graph to show the rate of change for the red maple tree. Make a table of values. At the beginning of the study, year 0, the diameter of the red maple tree is 4 inches. The diameter grows at a rate of 0.3 inches per year. So we have the year 0, which is the starting. So this, whenever you have the x value be 0, that's when you know you're looking at your initial value. Okay? That, because since our initial value literally means our starting output, we're looking for when x equals 0. And if we're looking at a graph, then we're looking at the y-intercept. Okay? So use the values in the table to make your graph. So then they've just plotted it. It's super easy, which now it looks very similar to the silver maple growth rate. But if you notice the silver maple's growth rate, it has a line that's a little bit steeper, so the incline is a little bit sharper than the red maple growth rate. So let's go ahead and move on to the connected problems. So number 2 says write ordered pairs for the points that show the initial value in each graph. The silver maple, of course, when I scroll back up, it started at 0,3. And the initial value, like we said, is the starting output. So that's how much it was, or the diameter of that tree in year 0 when it started there. The diameter of the red maple tree in year 1 was 4. So the initial value here as an ordered pair would be 0,4. So what do the initial values represent in this problem? They show the diameter, which we just said, of each tree at the start of the study. All right, number 3, fill in the blanks to describe the rate of change for both functions. On the red maple graph, the vertical change over the horizontal change is 0.3 over 1. And the way we know that is vertically what's happening for, which one is this again? The red maple graph. We see that it's increasing by 0.3 every time. That's how much our hops are to get from one point to the next. But then horizontally, oh, sorry, whoops. That was vertically, my apologies. So it's increasing vertically by 0.3 every year. So if you just bring over your points to the y-axis, it increases by 0.3 every year. But then horizontally, which is side by side, it increases just by 1 every year. That's where they got the horizontal change. So the horizontal change is always the x-axis, and the vertical change is always the y-axis. Okay, so then we have actually the same thing for the silver maple graph. It's always vertical over horizontal, y over x. The change in y over the change in x. That's just our rate of change. Okay, so the change in y, which is how we get from diameters each year, is 0.5 for the silver maple tree. And the horizontal change is the change in year, which is just 1. So what are the rates of change representing the problem? The rates of change is the growth rate of the tree. The rates of change are the growth rates for each tree. Okay, and we move on to number 5. Which function has a greater rate of change, and what does that mean in this context? So the rate of change for the silver maple is 0.5, which is greater than 0.3 for the red maple. So the silver maple grew at a faster rate than the red maple. And we already talked about this on the previous page, but just to kind of summarize what we talked about, here you go. So the rate of change for the silver maple was equal to 0.5, which is greater than 0.3 for the red maple. So we can say that the silver maple grew at a faster rate than the red maple. Okay. And then the triad. The table and graph show how much money a store earns selling each team t-shirt and each team cap. Compare the rates of change for these two functions. So the number of t-shirts sold and the amount earned is in the table versus the number of caps sold and the amount earned. So you sell no caps, you earn no money. I'm just looking at the graph first. Then if I sell 1 cap, I earn $2. So 1 cap is going to give me $2. 2 caps is going to give me $4. And then so on and so forth. 3 is going to give me 6. 4 is going to give me 8. And 5 gave me $10. So we know for a fact each cap equals $2. Then if I look at my number of t-shirts sold versus the amount earned, then I know that my t-shirts are selling for $4 because 1 t-shirt sold gave me $4, 2 gave me 8, 3 gave me 12, and 4 gave me 16. So each t-shirt is $4. So the rates of change, if I'm looking at that, my initial value is 0 for both. But then to get from to To find my rates of change for both, all I need to do is find the change in my amount earned over the change in the number of caps sold for the caps, and then find the change in the amount earned and the number of t-shirts sold. So for the t-shirt one, I'll just do the amount over t-shirts. Rate of change will be the amount over caps. So, and I'll choose two of them. So I'll just use the first two here and the first two here. So for the amount earned, I have 8 minus 4. So 8 minus 4 over 2 minus 1. And that'll give me $4 is the change in the difference. And then 1 in the change in the number of t-shirts sold. So I know that my rate of change is 4, which matches the amount for each t-shirt. So you could have just stopped there. So we can assume that it'll be the same thing. For the caps, it should be 2, but let's make sure. So let's just work with the second one first and do 4 minus 2 over 2 minus 1, which is 2 over 1, which is 2, which checks out. So all we needed to find was pretty much the unit rate for each of them. Remember, going back to like 6th and 7th grade, we talked about what unit rate was. We just needed to find out how much each of these items were worth. So the t-shirt is worth $4 and the cap is worth 2. So you can say the t-shirt's twice as much as the cap. And that's pretty much it. So the rate of change for the t-shirts is 4 per shirt, and the rate of change for the cap is 2 per cap. And the rate of t-shirts is double the rate of caps. So that's pretty much it. T-shirts are $4, while caps are $2. T-shirts are twice as much as caps. And that is all for day 2.